Hello everyone, and welcome to today's webinar, Coding over Hot Dip Galvanizing, Improving Communication and Specification. My name is Dustin Young, and I will be moderating today's webinar. This webinar is brought to you by SSPC and is part of our 2020 SSPC webinar series. If you would like to download a copy of today's webinar presentation, a PDF of the slides can be found in the handouts section of your GoToWebinar control panel. Before we begin, I want to take a moment to describe the format for today's webinar. The main presentation from Elena Fossa of the American Galvanizers Association will last about 45 minutes. It will then be followed by a brief question and answer session. During the Q&A session, you will be able to type in your questions for Elena in the questions box that can be found in your control panel. After today's webinar, you may test your knowledge and earn credit from SSPC by taking the webinar quiz. The quiz is free to SSPC members and is $25 for non-members. To learn more, visit the link listed on the screen where it says register here. Now I would like to introduce today's speaker, Elena Fossa. Elena Fossa is a senior corrosion engineer for the American Galvanizers Association and has been an active member of SSPC since 2015. Elena provides assistance to architects, engineers, fabricators, owners, and other specifiers regarding technical issues in the processing of hot dip galvanized steel. Elena also manages AGA's studies and research on performance, application, and processing of hot dip galvanized steel. And now I would like to turn things over to Elena so she can educate everyone on today's topic. Elena?
All right, thanks, Dustin. This is a hot topic for all of us here in the hot dip galvanizing industry, so I certainly welcome your questions or experiences on these topics at the end of the webinar. Hope everyone's doing well today. Today, I'm going to focus on very briefly on duplex systems, which is painting or powder coating over hot dip galvanizing. But to make sure the paint or powder coating will adhere successfully to a galvanized surface, I'm really going to focus on topics that are often overlooked but are absolutely critical in terms of improving communication, clarifying responsibilities, and to avoid common challenges. There are also specification language and research updates that I'm going to share with you today. These can also assist you in these types of discussions. And then we'll finally talk a little bit about maintenance of duplex systems at the end. Before I begin, just a little bit of background information about the American Galvanizers Association. We are a nonprofit trade association established in 1933, and we serve as a unified voice and provide expertise in the after fabrication batch hot dip galvanizing industry. We're available for free technical support in North America, and we also provide marketing and technical resources for our member galvanizers. So before we dig into some of the details regarding specifying duplex systems, maybe not everyone is equally familiar with that terminology of a duplex system. A duplex system is a generic term used in the industry for painting or powder coating over hot dip galvanizing so that you can achieve the benefits of hot dip galvanizing with the benefits of a protective coating system as well. And when we say hot dip galvanizing, I'm specifically talking about the batch hot dip process that's performed after fabrication. So this is where steel parts are sent after fabrication, and then these assemblies are going to be immersed in a series of pre-treatment tanks to chemically clean the steel. Then those same parts will be placed in a kettle of hot molten zinc, and that will form the galvanized coating by metallurgical reaction. Hot dip galvanizing provides long-lasting corrosion protection in atmospheric environments, and it provides very durable and long-lasting coating. Meanwhile, the paint or the powder coating, that will provide additional corrosion protection and then also allows color to be added into this overall system. But duplex systems are unique in that there is a synergistic effect that occurs between the coatings. How that works is the exterior layer of paint or powder coating will slow down or prevent the rate at which the hot dip galvanizing is consumed. And then once that paint layer has weathered down or become damaged, now the zinc beneath will be able to provide cathodic and barrier protection as well. As a bonus, the hot dip galvanized coating prevents underfilm corrosion, and that actually allows paint to last about 50% longer than it would if that same coating was applied over bare steel. And the final result from that is corrosion protection that lasts 1.5 to 2.3 times the sum of the paint life and the galvanizing life if no maintenance were to be performed. And there are additional benefits in terms of overall life cycle costs despite purchasing 2 coatings up front. However, if the galvanizing is never exposed to the environment, meaning that routine maintenance is performed, then the overall system can actually last indefinitely. But we'll talk about maintenance at the end though. So because of these benefits, duplex systems are becoming more common in various industries, especially in applications where we're looking for extended paint maintenance cycles, or there may be exposure to harsh soils or harsh chemical applications, even marine grade applications. Aesthetics and color are often at the top of reasons why hot dip galvanizing is painted or powder coated, just simply for aesthetics as well. The key to a duplex system's success in these types of applications is that they must be specified, designed for, prepared, and applied correctly. There was a previous presentation in this year's SSPC webinar series that already discussed some common failures, design challenges, inspection and quality concerns that can be present with duplex systems. So I'd really encourage you to visit that webinar recording if you get a chance for additional information beyond the scope of what I'll focus on here, which is mostly communication issues specific to specifying and preparing the galvanized surface. The reason that is because many do not realize that duplex systems are often bid by 2 different contractors. And so it's true that some hot dip galvanizers, they'll market and sell their own duplex systems, and then other galvanizers may partner with a nearby paint shop and they'll provide an all-in-one duplex coating surface. However, it's much more common to see these bid as 2 separate contracts. And so when hot dip galvanizing and paint are bid separately, the galvanizer may not be aware that that part is going to be painted. And then beyond that, the painter may not be expecting that galvanized steel is what will be arriving at their shop. This becomes a problem because the standards for hot dip galvanizing, they allow minor surface conditions to be present. There's roughness, bumps, oxidation, high spots, or other areas where we can have excess zinc, which normally are acceptable because they do not impact the level of corrosion protection you can get with hot dip galvanizing when it's used as its own coating alone. However, these exact same surface conditions may negatively affect adhesion of a paint or powder coating applied over galvanizing. So these conditions are not acceptable if you're looking to coat over the galvanizing. An even bigger problem is that it's very unlikely that either galvanizer or paint party was aware to price in the extra work needed to elevate the galvanized surface finish to the point where it's going to be acceptable to paint over. Practically speaking, these intermediate steps between galvanizing and surface prep for painting, they might not get discussed on a project by project basis. And when that occurs, some of these critical galvanizing surface preparation steps that I've listed here, like proper selection of repair materials, sufficient smoothing and cleaning before painting, all of these types of issues, they may end up being performed to a lower quality standard or just completely skipped entirely. Fortunately, there is a lot of information available to help you in specifying duplex systems on a project by project basis that will hopefully avoid a lot of the common failure methods related to surface preparation and communication issues. First, there are established standards that you're going to want to be familiar with for preparing the hot dip galvanized surfaces for painting and powder coating separately. ASTM D6386 is the standard we'll use for preparing the galvanized surface for paint. Meanwhile, ASTM D7803 outlines the necessary preparation steps for the galvanizing for powder coating application. These standards will be the same whether or not you're talking about a shop, a field, or a maintenance application. The two standards, they're quite similar actually, and this is where the requirements are located for smoothing, cleaning, and profiling of the surface. With the powder coating, there's just going to be an extra step required in order to prevent outgassing. However, these standards, they have a variety of options for surface preparation methods listed within them. So just specifying these documents alone, it can leave things open to interpretation. And instead, there are some important questions that you might want to ask to help determine which options within these standards may be suitable on a project-by-project basis. Referenced within both standards is a specification for sweep blasting to profile the hot dip galvanized surface. That is SSPC SP16, which is brush off blast cleaning for non-ferrous surfaces. This abrasive blast cleaning standard, it's the most common practice for cleaning and profiling the hot dip galvanized surface, and it includes specific steps in that standard to help avoid damaging the coating. If abrasive blast cleaning is desired, but SSPC is not specified, then what can occur is a painter that may be unfamiliar with hot dip galvanizing, they might use abrasive standards intended for cleaning bare steel, and that can result in peeling or excessive damage to the galvanized coating. So it's important to be aware of that standard as well. Finally, it's going to be the specifier's responsibility to select the paint or powder coating system based on the intended use of the part, the application method, and the environmental concerns, and the desired aesthetics for the project. So you can consult a paint manufacturer for the proper paint selection. You can also reference SSPC Guide 19, which has been developed to help select an appropriate coating system for a duplex system based on exposure environment. Once these standards have been specified or referenced, next there's going to be responsibilities within that standard that need to be delegated or even shared between the specifier, the galvanizer, and the painter. And so you want to communicate and discuss all of these topics that I'm going to talk about today before the work will begin. The specifier is going to be responsible for informing the galvanizer and the paint applicator that the part will be painted after galvanizing or powder coated. What this does is opens up that line of communication between all parties, and then from that step you can further confirm design or specification decisions that might impact their mutual responsibilities. Once all parties know that the material is going to be painted or powder coated, the galvanizer will be responsible for avoiding any type of galvanizing post-treatments that are commonly applied in order to help preserve the galvanizing appearance from staining, or it might help to cool the parts for handling. But there are certain conditions that are known to impact the adhesion of any applied coating afterwards. For example, when parts come out of the galvanizing kettle, they're very hot and they can't be handled right away. So often they're rapidly cooled by water quenching or chromate quenching solution. These processes, they have been known to negatively affect adhesion of the coatings that are applied afterwards. So unless the galvanizer is made aware that that material will be painted, they won't know to avoid these galvanizing post-treatments. And so the customer or the painter beyond that will not be able to visually tell the difference either between items that have been quenched using these methods or not. Next, the galvanizer and the coating applicator must communicate directly and then agree on responsibility for smoothing out any surface conditions that might present a problem for painting. Finally, the coating applicator is always responsible for the remainder of the surface preparation requirements beyond that smoothing, like cleaning and profiling. And in the case of powder coating, they'll also be required to perform the steps to prevent outgassing. The primary specification for hot dip galvanizing in North America is ASTM A123, and that standard was updated to include some language that would help highlight the potential for communication gaps that might occur related to smoothing of the surface in between the galvanizer and preparation for painting. This new verbiage, it highlights the need for that mutual agreement between the galvanizer and the purchaser, which is really important because not all galvanizers may have the capability to perform all of the surface smoothing at their facility. And at the same time, not all painters are expecting to incorporate all the steps for surface smoothing into their project bid. So similar verbiage was also included into those surface preparation standards, ASTM D6386 for painting and D7803 for the powder coating. And that was recent up in 2019. Once all the parties have been informed that the hot dip galvanized steel will be coated over, the next set of slides I'm going to show you are going to be some discussion aids to help you in translating the surface preparation standards for galvanizing that you find in D6386 and D7803 into maybe some practical terms so that, you know, optimization can be had between cost and turnaround time and just general overall effort. So the first discussion point that you're going to want to clarify is the acceptability of any post-treatments that may be performed by the galvanizer. So I already briefly touched on this, but that the galvanizers apply post-treatments after galvanizing, such as water quenching or chromate quenching, that's going to help them accelerate cooling. There's other methods that can be used to dull surfaces or help prevent wet storage stain, or that white, dusty corrosion products that can tend to form on the surface during storage and transportation. And some of these post-treatments, they're going to alter the surface chemistry. They're going to passivate the coating. Phosphatizing or a zinc phosphate quench solution, that can actually produce, that will passivate the surface, but also produce a surface that is acceptable for painting. While others, like the chromate quench or the water quenching, will leave us with a surface that is difficult to top coat. Although water quenching does not change the surface, a water quench bath typically contains contaminants that will be deposited on the surface and will interfere with paint adhesion that are difficult to see. When all parties are informed about the duplexing, then the galvanizer, they're going to be held responsible for ensuring that these passivations are not performed. Next, the elevated aesthetic requirements for hot dip galvanizing, those must also be communicated to all parties. Like I mentioned before, typical imperfections and roughness in the galvanized coating, those are often acceptable on a normal basis, but if we're painting or powder coating the galvanized surface, there are conditions which would impact the coating adhesion, and those all need to be addressed. I've listed some common examples here, such as roughness and sharp areas, the presence of dross inclusions, which are bumps that are really zinc and iron intermetallic alloy inclusions. There is the inclusion of surface or bath oxides that are black in color called zinc skimmings. There's also zinc runs or other areas of excess zinc. Those can be some common examples that you may want to specifically call out for addressing. The next discussion point between parties would be galvanizing repairs. This topic is not specifically addressed in any surface preparation standard for paint or powder coating, but the acceptability and responsibility for any repairs is definitely worth discussion for a variety of reasons. So galvanizers, they're actually required to deliver, the galvanized product with full coverage, but some repairs are allowable to be performed at the plant, and they must be performed prior to acceptance. There are 3 methods that are allowed for the repair of all hot dip galvanized coatings, according to the specification ASTM A780. Those 3 methods are going to be zinc metallizing, zinc solder, and the use of a zinc-rich paint. Unless explicitly specified or agreed to, the galvanizer may select any repair material from this list. Regarding painting or powder coating afterwards, if you're utilizing zinc spray metallizing or zinc solder for the repair of hot dip galvanized coatings, there's not going to be any additional clarification here that is required. But if the galvanizer intends on using a zinc-rich paint for repairs that are conducted at the galvanizing plant, the recoat time windows really should be evaluated by the specifier, because practically in terms of logistics, you may not be meeting those recoat windows by the time it gets to the paint booth. Depending on the compatibility of any zinc-rich paint with the paint or powder coating that's going to be applied overward, that also should be discussed directly with the paint manufacturer to check that compatibility. Also, that's important to consider because a galvanizer, from galvanizer to galvanizer, the zinc-rich paint products that are available can vary quite a bit. Once any galvanizing repairs have been completed, the surface now must be smoothed before it is cleaned and profiled to remove those surface conditions I mentioned earlier that can impact adhesion. The primary goal here, we're just looking to remove any high spots, any roughness above and beyond ASTM A123 standard galvanizing finish to help us achieve a smooth enough surface that's going to be acceptable for the paint or powder coating. But who performs this? Is that the galvanizer? Is that the painter? Is it both? Often this particular step is the one that's most overlooked and left out of project bidding as well. The galvanizer can be made capable of smoothing out the coating. They can take that on, that responsibility at the galvanizing plant, but maybe not all have the capability or space. So it kind of varies from galvanizer to galvanizer. But in all cases, a combined effort between the galvanizer and paint applicator, that can actually go a long way to making sure that any problematic areas are all identified and smoothed. When it comes to actually smoothing the surface, ASTM D6386 and D7803, they allow you to specify hand tool cleaning or power tool cleaning for surface smoothing. However, if you're working with someone that's unfamiliar with hot dip galvanizing and duplex systems, be aware that they could easily damage the galvanized coating when working with power tool cleaning. So to take a lot of care in that procedure. ASTM D6386 and D7803, they mention that galvanizing thickness should be confirmed after surface smoothing to confirm excessive damage has not occurred. But if it has, it can be repaired, the coating of any size in a localized area using those same repair methods that I mentioned before. So we talked about kind of the roughness or high spots, but it also may be desired to fill in low spots or depressions to even out divots or indentations in the galvanized coating so that to further achieve that smooth surface. We also see this when looking to paint over vent and drain hole plugs, which have been pushed in to fill in vent and drain holes. Sometimes these are pushed in a little too far, and there can be a discrepancy in the height of the coatings there. So I see this most often on projects that have elevated smoothing or aesthetic requirements, such as architecturally exposed structural steel, but in general, also just other project types of high visibility. If you're looking to achieve a smooth, paintable surface in these areas, you may need to specify a filler material that the galvanizer or painter can easily apply. But you'll want to confirm with the paint manufacturer whether that specified filler material is going to be compatible with the primer coat. And just be sure to identify who would actually be responsible for acquiring and then applying and smoothing that filler material. Once the surface is smooth, the steps required next are to clean and profile the surface. But the steps involved and required will depend on the time that's allowed before painting, where zinc oxides and zinc hydroxides will form on the surface, and then eventually over time and exposure to natural wet and dry cycles in the environment, it'll develop a protective patina, and that is made out of zinc carbonate. An earlier SSPC webinar in this series went into a lot more detail about how to identify these classifications and further discussed some difficulties in practically identifying them. So I'm not going to delve in too much there. I just really want to focus on the practical logistics of many projects that often translate to the fact that the galvanized pieces leave the kettle and they reach the paint booth, but they're not ever, they don't ever make it in time to maintain within the newly galvanized condition. There's going to be zinc oxides and zinc hydroxides very likely to be present in that time period, and these will need to be removed before the parts can be successfully painted. This is what's known as a partially weathered surface once a galvanized surface has started to allow surface oxidation to occur. And it's the most common surface condition that the coating applicator is going to run into. Only in cases where the galvanized steel has been left to weather over a year or has fully formed the zinc patina, meaning that there's only zinc carbonate on the surface and none of those problematic oxides or hydroxides, that is when the standards do recognize this condition is a little bit easier to paint and there are less preparation steps required. But for the purpose of this presentation, I'm going to focus on the partially weathered galvanizing and some of the communication issues that can arise with the surface preps required for that case, since it does require the most preparation steps that are defined in the standards. So once the condition of the galvanized surface has been properly identified, or if it's been assumed as a partially weathered surface, you'll need to clean the surface of dirt, oils, grease, or other surface contaminants. ASTM D6386 and D7803, they mention organic contaminants and surface oxidations can be removed with an alkaline solution, an acidic solution, or through solvent cleaning. But especially where acidic and alkaline cleaners have been used, you want to avoid letting that sit on the material and attack the coating during cleaning. You want to be quick with it. And so it's strongly recommended to heed those suggestions in the standard that mention that time period, but also rinsing that material thoroughly and preferably rinsing multiple times. Anytime that this is left unhighlighted or unspecified, and a paint applicator may not be familiar with galvanizing, they may not feel the need to heed those recommendations. And so highlighting this concern can aid in this in preparing duplex systems. Next, most galvanized surfaces will need to be roughened to promote adhesion of the coating that's going to be applied. Although weathered galvanizing is known to have some natural roughness that can be painted over without additional roughening, if you're applying a industrial or marine grade coating or a coating that has significant peak height or roughness requirements, that may not be sufficient to paint over as is. So regardless, this is where the specifier kind of needs to step in and clarify whether you're dealing with newly, partially, or fully weathered galvanizing. And then needs to give some input on the methods that are available for surface roughening. So the available methods, depending on whether you're painting or powder coating, may be brush off blasting for SSPC SP16, which we mentioned earlier, that is the most common. Surface grinding in accordance with SSPC SP11. The use of a zinc phosphate solution, or the use of a wash primer or other type of acrylic pretreatment. So I'm going to review some of the considerations that can arise in each case. But if you leave the roughening requirements unspecified and left fully up to the contractor, there may be instances with an insufficiently roughened surface for the coating you're trying to apply over galvanizing. The most commonly specified method for preparing galvanized steel for paint or powder coating is that brush off blasting standard that I mentioned earlier, SP16. So this applies not only to galvanizing, but is also applied to stainless and other non-ferrous metals like aluminum. This standard requires the abrasive blasting for galvanizing that it'll be performed at 30 to 60 degrees and at lower pressures. You'll also use more rapid nozzle movement and use softer and finer abrasives to achieve a minimum 0.75 mil profile height. And then it'll include procedures to assist without damaging the coating in that process. To the right here, there's some images I'm showing you here. Hot dip galvanizing comes in a wide variety of initial appearances. On the left, you have what is known as reactive steel, which may come out a little more dull or matte gray. And to the right at the top, you have your typical bright and shiny hot dip galvanized coating. When these are abrasive blast cleaned, then the surface becomes more of a uniform matte and etched in appearance so that you can tell the entire surface has been blasted. So I show that here on the bottom left. It does look much more similar to the initial matte gray appearance. So someone unfamiliar with hot dip galvanizing, they'll want to look out for that, to look out for the etching appearance as well, to make sure the entire surface has been sufficiently cleaned. What you really want to avoid is shown here on the bottom right. This is blasting at 90 degrees head-on with harder, larger abrasives and at typical pressures and standoff distances you would use to clean bare steel. What happens is you'll end up overblasting and removing a lot of the zinc thickness, sometimes all the way removed as well. This not only creates a rough surface condition, which is very difficult to paint afterwards, but it can also be quite difficult to repair in a way that doesn't impact the longevity of the project. Within SSPC, SP16, and also within D6386 and D7803, there are recommendations for organic or soft abrasives that can be used to minimize damage to the galvanized surface. These typically are organic media or media that have a Mohs hardness value less than 5, and you may consider finer mesh sizes as well. Organic media such as corn cobs and walnut shells, but we've also seen, crushed glass makes that recommendation list as well. These recommendations, they can certainly be suitable for coatings that require clean, but maybe only a lightly roughened surface. But these recommendations may not always fit the bill if you're trying to achieve the type of rough surfaces required for maybe thicker coatings or industrial grade coatings that may require significant profile height or angularity, such as your epoxies, your high build coatings, polyurethanes. So in the marketplace, and to get around this type of issue, specifiers and applicators, they've been looking outside of the typical abrasive recommendations, and instead they've been turning to harder or coarser sizes available from mineral sands or other inorganic products and mixtures. Overall, the use of these products have been met with mixed success. And the reason for that is, you might hear someone say, oh, I had great success using, garnet over galvanizing, and then someone else could have had a poor experience. The reason for that is without certain mitigations, it can be very easy for someone unfamiliar with hot dip galvanizing to damage the surface with these materials. Another issue is the blast media does not give the same surface roughness properties, such as peak height, when you are using them over on a galvanized surface versus a bare steel surface. So you can't just take the spec sheet from an abrasive supplier and then apply that directly to a zinc coated surface. So to kind of wrap our head around this issue, the AGA completed a study last year that evaluated different types of mineral sands and inorganic abrasives. And what we found was that the nozzle pressure and abrasive size were two of the most influential factors related to changes in the surface profile properties and the likelihood of coating damage. If you're looking to achieve more in the range of like a 2 to 4 mil profile height with hot dip galvanizing using these type of materials, it's doable. But you will need to dial back pressures and standoff distances when blasting. But one thing to consider in your conversations with the coating applicator is that the blaster will need to know that you are aware that these types of measures used to protect the galvanized coating, that's going to require a significantly inefficient use of the abrasives, and they may not be used to that type of requirement. Generally speaking, in our investigations as well, we found that when using these types of harder, larger abrasives, 0.4 to 0.6 mils reduction in coating thickness may be somewhat typical. And because the longevity of the hot dip galvanizing is directly related to the amount of zinc present on the part, this may appear as an undesired quality. And so you may want to evaluate that on a project by project basis to determine if that's an acceptable trade-off in terms of overall longevity. For projects where you're going to be maintaining the duplex coating, the painting or powder coating over, this is going to be much less of a concern. This is more of a concern for projects where you're not looking to maintain the duplex system. You're just looking for a one-time, greater longevity product. The typical galvanized coating on structural steel is often in the neighborhood of 4 to 6 mils. So even considering a reduction, many times there is sufficient zinc that remains above the initial specification requirements after blasting. Another thing to consider with duplex systems is that many duplex coatings, they're going to be maintained for appearance. So again, this reduction in coating thickness, you need to determine if that's acceptable for the project. If there is the potential for low coating thickness, you can address that in the project standard, whether that needs to be repaired or just addressed in some way. We also get asked about the use of metallic abrasives and hot dip galvanizing. We did test embedment, and we did find that a lot of abrasives, including metallic abrasives like steel grit, embedment tends to be quite common. The zinc is more of a softer surface on the soft ADA layer, the pure zinc layer of the galvanized coating. And that may or may not be of significant concern regarding galvanic corrosion, and so that needs to be also addressed by the project. But if you'd like to learn more about the research we've done on the abrasives in preparing galvanizing, do feel free to contact us for more information. Another method that is available to roughen the coating is the use of grinders and sanders. The details are prescribed in SSPC SP11 for power tool cleaning to bare metal. So that's going to provide a profile of at least 1 mil. So if you're looking to achieve significantly greater profile heights, you may want to consider a practical test to determine whether you need to be looking at abrasive blasting to achieve that instead. When performed carefully and with low force, this can be a suitable preparation method for many coatings, but it is possible to damage or thin the coating if someone goes a little crazy with the power tools. So grinding zinc, for example, that doesn't produce any sort of sparking. So if you do see sparks with the use of grinders and sanders related to galvanizing, it means you've somehow made it all the way down to bare metal. ASTM D6386 does allow up to 1 mil reduction in coating thickness if this method is selected. So again, that's another topic that should be evaluated on a project basis. Grinders and sanders also produce significant zinc dust on the parts in comparison to other roughening methods. So this can lead to more rapid zinc oxide formation in humid conditions. So you want to make sure that if this is going to be used, that there is a way to get from surface prep to painting as soon as possible. A wash primer or a self-etching primer, this is where we look at a metal conditioner to neutralize surface oxides and hydroxides, but it'll also etch the galvanized surface to give you a surface that's suitable for painting. SSPC Paint 27 addresses more of the material application and inspection of wash primers, and there are other types of options to meet environmental requirements as well. But when you're considering a wash primer, the topics to discuss in terms of duplex systems, is again the use of galvanizing post-treatments. Wash primers are not going to be able to be applied over a water quenched or chromate quenched surface, just like normal, but they also cannot be applied over a zinc phosphated surface. You should also discuss the compatibility between the intended wash primer and the top coat. The wash primers are not typically compatible with all coatings, so you may present challenges with thicker coating systems as well. Another method for profiling the galvanized surface is to passivate the surface with a zinc phosphate solution. We kind of touched on this before. So this solution, it reacts with zinc metal on the surface, and you get a layer of zinc compounds that are tightly bonded to the surface, protect from oxidation, and you also get a roughened surface out of that, which you can paint or powder coat over. There's a variety of proprietary solutions designed to work well over galvanized surfaces. You can brush apply, spray apply, but there's also some galvanizers that offer this as a post-treatment at the end of their galvanizing line as an immersion process. So you'll want to consider the manufacturer's recommendations for the paint and whether the type of surface produced by the zinc phosphate treatment is suitable. There's also some concerns regarding baking temperatures and exposures above 535 Fahrenheit. The zinc phosphate conversion coating, it can turn into a powdery substance above this temperature that can affect adhesion. With pre-baking, that is the next step specific to only powder coating. So once surface roughening has been performed, you're ready to apply the coating, but you need this intermediate step between surface prep and application of powder coating. And this is to prevent pinholes or blisters in the powder coating that can occur if you have any trapped water vapor or air within the natural roughness of the zinc coating that can expand and then leave the surface during curing of the powder coating, leaving you with those small craters or blisters. The reason I bring this up is because ASTM D7803 includes a procedure for pre-baking that needs to be clearly communicated to all parties that what the pre-bake temperature will be. So it's typically about 50 to 65 degrees Fahrenheit above the curing temperature. For most powder coatings and equipment capabilities, this is not a big concern or issue, but at the high end of cure temperatures, you may need to consider capabilities and then consider any limitations if you're using that zinc phosphate treatment. Finally, you're ready to coat the galvanized seal, and the powder coating should follow baking as soon as possible. Again, you're always concerned about making sure that you're not allowing any time for zinc oxidation to begin. All right, the last thing I'll mention related to specification and communication as it relates to surface prep is maintenance painting, which often doesn't get talked about very often. When hot dip galvanized steel is painted or powder coated, more often than not, that coating is maintained, probably for aesthetics, but also for increased longevity, depending on the project. Where you have just minor maintenance or touch-up of the paint, you may or may not be dealing with the exposed galvanizing layer. But either way, the contractor needs to be very clearly alerted that this is a duplex project, so that when they go in to make repairs or smooth out areas or feather in repairs with a grinder, or if they're using abrasive blasting, we want to make sure that they're aware that galvanizing layer is underneath so that they don't damage that layer. If we're looking at a full recoat, removal of the existing coating, obviously there's a lot of ways to do that, but you would want to consider methods that are going to preserve the hot dip galvanized coating. And so you can use paint strippers or power washing as long as pressures are held below 1450 psi so that you avoid damaging the coating. If the contractor is aware of the galvanizing underneath, it may be possible to preserve the original surface profile beneath. That can still be preserved underneath there. So maybe the only cleaning is required in the field, and so you don't have to spend extra time roughening the surface. However, you may want to still be prepared for any unknown or damaged conditions. Once the galvanizing is exposed, you may want to look at performing an inspection of the hot dip galvanizing, but then also communicate what those requirements are. There isn't an established standard for this particular step, but do keep in mind that the same elevated requirements for galvanizing finish that we talked about relative to surface smoothing, that still applies to maintenance coatings. So these elevated smoothing requirements need to be re-communicated when we're talking about maintenance painting as well. Where necessary, or if the coating was damaged in the process of preparing for the maintenance coating, field repair of the hot dip galvanizing of any size can be performed in the field. If we're performing galvanizing repairs at this stage, you also want to rediscuss the use of materials for repair, just like when we talked about it for new projects. If the zinc-rich paint is being used for repair, you also want to talk about coating compatibility with the coating system to be applied atop it. So another thing to be aware of with galvanizing repairs is who have you actually assigned to be performing the galvanizing repairs? It may seem like a silly question, but sometimes a separate galvanizer may be called out for the repairs to the galvanized coating alone, or they might be performed well ahead of painting. If zinc-rich paint was the material of choice for repair, be sure to, again, rediscuss those recoat windows, especially if the responsibility for galvanizing repairs is assigned to a different party than the maintenance coating applicator. All right, that wraps up some of the discussion points that I had. I hope that I was able to communicate that the specification of duplex systems, it's simple. There are a lot of guidance out there for you, but to succeed, you really need clear communications about the different options available to you in the standards, and that will help also with a clear division of responsibilities so that you do have a successful duplex system. AGA has a lot of resources, and we have a lot more information about duplex systems on our website, or you can always contact us directly with our technical resources. So that wraps us up, and if anyone has any questions, I'm happy to answer.
Thank you, Elena, for that presentation. Now we will take some questions from attendees. You can type your questions into the questions box in your control panel. We may not be able to answer every question based on content and time restrictions, but we will try to get to as many as we can. So Elena, someone asked the following question. Is there a test I can specify to confirm whether a chromate quench has been performed or if another type of passivation is present on the galvanized steel?
Yes, that's a great question. ASTM B201, that contains a procedure specific for detecting chromate conversion coatings on zinc-coated steels. Basically, you would develop a lead acetate solution and place drops on the surface. If that solution turns dark or black, it means you're reacting with zinc metal and there is no passivation present. And it will be clear if there is a passivation, clear in color if there's a passivation. That same test can be used for other passivation types as well, since you're really just testing whether or not you get a reaction with zinc metal or not.
Okay, thanks. The next question, when inspecting duplex coatings, what methods are used to distinguish galvanizing thickness from liquid coating thickness?
Sure, so there's two ways that that's handled in the field. Many can measure the galvanizing thickness with a magnetic DFT gauge just after surface preparation, so that you know how much galvanizing thickness to subtract from the final reading. That's because the surface preparation steps themselves may not give you the same reading afterwards as the freshly galvanized part, especially if it's ground smooth and things like that. But since you're going to be measuring probably over a roughened surface, you may want to be aware that there can be some inaccuracies there. There's also a duplex coating gauge in the marketplace, and it has a probe. There's a probe that will measure and then also display zinc and paint or powder coating thickness all in one reading.
Okay, thanks. Our next question, does hot dip galvanizing have an impact on holiday testing of the paint/powder?
That's a good question. I do not know the answer to that. So I would have to get back with you, but typically there's not going to be any sort of voids or change in electrical conductivity due to the presence of zinc on the surface.
Okay, thanks. The next question, where can we find standard language for use in purchase orders for duplex systems, especially when the galvanizer and painter are two separate contracts?
Yeah, that's a great question. So ASTM D6386 and D7803, they do contain a lot of language that you can incorporate, especially once you've had the chance to kind of sit through the various options, and you can cut the ones that don't apply to your project. So you can use that as a basis. But in addition, the AGA has a kind of guide example specification for duplex systems that kind of talks about this surface smoothing issue and the separate time between the galvanizing standard and then moving on to the surface preparation, and to kind of clarify some of those gaps. So I would encourage you to check out those resources, or I can send them out along with information on this webinar.
Thanks. Our next question, do you suggest galvanizing on all types of steels? If not, which steels are recommended for galvanizing?
Sure. So hot dip galvanizing is suitable for a wide variety of steels. Anything iron containing is, and that also contains nickel, is going to have the sufficient chemistry to form a galvanized coating. However, there are some steels, depending on manufacturing or fabrication factors, that may not be suitable for hot dip galvanizing. For example, anything that has been excessively cold worked, or anything that has been is very thin walled or heavily framed and constrained structures, they may have issues with the heat of the hot dip galvanizing process and may tend to distort, warp, or embrittle during that process. And so there's a lot of information that could be a whole hour-long topic on itself, designed for hot dip galvanizing, but there are a lot of resources on the AGA on that topic, including design details that can avoid those issues. Also, steels that have an ultimate tensile strength above 150 KSI, these can be susceptible to hydrogen embrittlement. So if you're dealing with abrasion-resistant steels, that type of thing, we'd want to steer more away from those types of steels.
Okay, thanks. We'll ask a few more questions. The next one, can we use duplex systems on high temperature systems above 600 degrees Celsius?
Good question. So, you would have to look at both the hot dip galvanizing requirements and the requirements for the paint performance themselves. So those would be two separate things to investigate. One would have to come from the paint manufacturer themselves. But in terms of hot dip galvanizing, once you get above about 450 degrees Fahrenheit, the hot dip galvanizing may be susceptible to peeling or separation of the top layer of the coating. So for extended applications, we want to stay below that. However, the melting point for zinc is, into like 790 degrees Fahrenheit. So as long as we're not in that territory, you're not at risk of damaging the coating in a single short-term application.
Okay, we'll take two more. The next one is it necessary to weather the galvanizing element and then apply the coating/powder?
It's not necessary. So the steps I talked about today, those are all of the steps that would be required for a partially weathered surface or one that didn't get fully weathered. So you would perform all the cleaning steps, from cleaning, profiling, removal of any storage staining, things like that would all be considered all the steps required for the intermediate stage. But those are still successfully painted all the time. So but painting a weathered product is somewhat easier.
Okay, our last question, Can inorganic zinc silicate be used as a primer in place of zinc rich?
Yes, but it may not always be necessary. So it, if you have a inorganic zinc rich primer that you're trying to apply over the hot dip galvanizing, I would just, have a discussion with the paint manufacturer for looking at the overall coating design and see if that's necessary, because the hot dip galvanizing alone is already providing you the benefit of a barrier coating and also cathodic protection. So those same benefits are already afforded by the galvanizing you would be applying to.
Okay. Thank you, Elena, for answering those questions. We're approaching the end of our session now, so I just want to review a few closing items before we conclude. As I mentioned at the beginning of today's webinar, those of you looking to test your knowledge on today's webinar can register for the quiz at the link shown. This link, in addition to a link to rewatch today's webinar, register for future webinars, and learn more about training and certification courses related to today's topics, can be found in a follow-up email that will be sent to you after today's session has concluded. There will also be a brief survey after today's webinar, so you have a moment to fill that out. We'd appreciate your feedback. Thank you again to Elena Fossa for presenting today's webinar, and thank you to all of our attendees for your participation. We hope to see you in future webinars. Have a great day.